So in today's lesson, we are going to start with a quick recap again, which we were covering in previous two lessons. So this is again talking about finding the gradient of a curve. So the quick recap is, you know how to find the gradient of a line. So if you have this line and where you have 2 points 1, 2 and 2, 4, either you can use the graph to find the slope, or you can use the formula, which is y2 minus y1 divide by x2 minus x1, and then you can use this formula to find the slope. So you already know that, but the question is that we want to find the gradient of a curve, and we started with last time y is equal to x square because that's the easiest one to start with, and this is the graph of y is equal to x square, and I have 2 points here. And I'm keeping the same points which we were using in the videos. So one in the previous lesson, so 1, 1 and 2, 4. And what we did is we fixed point 1, 1, and we know the line which connects 1, 1 and 2, 4 is called chord, and we know how to find it's a line. So we know how to find the slope of this chord, which is in this case is 4 minus 1 over 2 minus 1. So that is 3 over 1. So the slope is 3. And now what we did is, because this is the slope of a chord, but we want a function which can help us to find the slope of this curve at any point. So what we did in the previous lessons also, so we fixed this point 1, 1, and then we changed the point. So let's start with 2, 4. And if this is the case, we already know the slope is 3. And what we did is, so this table is not for finding the slope between 1, 1 and 2, 4. So what I'm trying to do now is, I'm trying to move this point 1, 1 towards 2, 4. This is what you were doing. This is what I explained in the previous video also using autograph. And then I asked you to notice that. And then what happened is, when we move 1, 1 towards 2, 4, so I can maybe choose another point. So 1, 1, 2, 4 we already know. So let's say if I have 1.5, then because y is equal to x square is our equation, so which means if you have x which is equal x is equal to 1.5, then this is 2.25, and then you can find the slope again. So 4 minus 2.25 divided by 2 minus 1.5, so you can find that 1.75 or 0.5, and then your value which you get here is going to be bigger than 3. So as you move your point 1, 1 towards 2, 4, what will happen here is, the gradient in this case, when we round it to the nearest number, it will be closer to 4. And then when we did the same thing with 3, 9 and fixed the point 1, 1, so 1, 1 is fixed, and then we start moving 1, 1 towards 3, 9, then the slope will be 6. And when you have 1, 1 again moving towards 4, 6, then the slope in this case is 8. And 1, 1 moves towards 5, 25, then the slope is, in this case, is going to be 10. So now we need to look at the pattern here. And if you look at here, this is the linear relationship. And why this is linear? Because when you have a first order difference, this is plus 2, this is plus 2, this is plus 2, which means in this case the rule for this one is going to be 2x. So I can see it. So when x is equal to, because the other thing which you can actually see here is, this is 4 and this is twice of x coordinate. This is 6, this is twice of x coordinate. This is 8, this is twice of x coordinate. This is 10, and which is twice of x coordinate, which means when you have y is equal to x square, then y prime or dy by dx is equal to 2x. So that is the rule for x square. Now we want to generalize this rule, okay? And so what we are doing now is, for y is equal to 2x square. Now you can do the same activity which I did last time, and if you don't want to do that activity, then it's exactly the same similar thing. The only change here is, in the previous one we had x square, now we have 2x square. So something is written in front of that. So what will happen here is, and what's happening here is, when you have 1 comma 2 and 2 comma 8, because when x is 1 your y coordinate is 2, when x is 2 y coordinate is 8, then the slope is 6 in this case. And now we do the same thing. Now we are going to fix 1 2. When I say fix 1 2 means it's not fixed, because we are moving this towards the point. So actually 1 2 is not fixed, sorry. So 2 8 should be fixed, or 3 18 should be fixed, or 4 13 32 should be fixed, or 550 should be fixed. So similarly in the previous one, when I said 1 2 is fixed, it's not. 2 comma 4 is fixed, 3 comma 9 is fixed, 4 comma 16 is fixed, and 5 comma 25 is fixed. So 1 comma 1 is approaching towards these points. So similarly here these points are fixed, and when you move 1 comma 1 towards these points, so notice that the slope in this case becomes 8. Here the slope in this case will become so here in this case the slope will be 12. Here in this case the slope is going to be, again, you can choose the point. So if you have 1 2 and then 2 8, then we know the slope is 6. Then instead of 1 2 you can maybe do 1.5. When it is 1.5, then you need to do 2 into 1.5 square. I'm not going to do that. That is your y coordinate, and then you find the slope, then this is going to be more than 6. And ultimately this is going to be, when 1 2 is going to move very close to 2 8, the slope is going to be 8. And then 3 18, slope is 12. And when you have 4 comma 32, the slope is going to be, in this case the slope is 16. And then if it's 5, the slope in this case is going to be 20. And then you can again notice, so again here you can see the linear pattern, and derivative is, so in this case the first order difference is 4, so it's going to be 4x. So y is equal to, y dash is equal to 4x. So, and again 8 is 4 times 2, 12 is 4 times 3, 16 is 4 times 4, 20 is 4 times 5. So then this becomes 2x. And the another way of looking at the derivative of y is equal to 2x square, which is quite easy, is also, we know the derivative of x square. We know if y is x square, y prime is 2x, then y prime for 2x square is going to be 2 times 2x, so that is 4x. So this is how you can also find out the derivative of any function. If it's x square, and if you have anything in front of that, then this becomes 2x square. Okay, now we are doing this with x square, but if you have, let's say you have y is equal to, let's say you have y is equal to x cube. Now in this case also, when you have anything, for example, let's start with the point 1 comma, when x is 1, your y is 1 as well. And then let's move this point again, and then I'm going to fix the point when x is 2, it's 8. When x is 3, it will be 27. When x is equal to 4, it will be 64. I'm not going to go further. And then we notice here, when you move 1 1 towards 2 comma 8, first let's start with the slope of a chord. Then the slope in this case is going to be 8 minus 1 over 2 minus 1, which is equal to 8 minus 1 is 7 over 1, which is 7. And when you will move this point closer to 2 comma 8, then what will happen here is the gradient is going to be 12 here. So again, you need this autograph here, or any application which you can actually see that the gradient is going to be 12. Or if you don't want to do that, what else you can do is you can use your GDC actually. So I would advise you to look at your GDC and try to find out. So maybe I can show you, just give me a minute. Okay, so if we use our GDC, so I can actually show you using GDC. So how can you use GDC to find out the, okay, so let me show you. So if you go to math, and then if you go to number 8, I don't know whether that's number 8 in yours, and then if you go to n derivative, and if we enter here d dx, and our function is x cubed, so I'm going to do x raised to power 3, and then I have to move this to, now if I want to find out, because look at what equation I have. So y is equal to x cubed, and x is 2 for the first one. So I'm going to show you when x is 2, enter, and then I got 12.001. If I round it to the nearest number, that's going to be 12. And that's what I told you before. Now, if I want to change it to, let's say, let me copy paste here. Okay, so there's a reflection. So let me up, copy paste. And now let me change x to 3 because that's the next point. And if I change x is equal to 3, you can see this is 27. And if I do this again for x is equal to 4, so let me change this to 4 now and enter. So you can see this is 48. Okay, so again one more time. So how did I do that? So I'm going to quit. Okay, so you went to math, and then this is your n derivative. So that is number 8 in my case. So sorry, n derivative here. Okay, so you can use GDC. So you go to math and then you go to n derivative. Okay, and you will be able to do that. So you will go d by dx and the function, and then x is equal to whatever is your function. So you can use your calculator to find the derivative at a specific point, but this GDC, you can't use GDC to drive any general rule. But I'm using this too, since either you use the autograph, any kind of a graphic calculator kind of thing like Desmos or autograph or GeoGebra to do that, or the easier way of doing right now is that using the calculator. I showed you that the derivative was 12 here, and then at 327 derivative is 27, and then it's 48. Now we need to look at the pattern here, and if you remember previously, this has to do something with x coordinate. So if you look at, so this is 12 and this is 2, so this is 2 times 6, yeah. And now we need to look at if there will be a pattern here. So if this is 3 and this is 37, so I can see that this is going to be 3 times 3 times 3. And if it's 4 and it's 48, so it looks like 4 times 12. But then maybe I need to 4 times 3 times 4. So it looks like 3 times 4 times 4. This is 3 times 3 times 3. And this becomes 2 times 2 times 3. So now if I look at the we need to look at if there's a pattern. So I can see this is 3, this is 3, this is 3. So this is 3 times, and now you can look at 2 times 2. 2 times 2 means it's 2 square here. The first one is 3 into 2 square. The second one is, so second one can be written as 3 times 3 square, and last one is 3 times 4 square. So we got 3 times 2 square, 3 times 3 square, and then we got 3 times 4 square. So this is what we got for 2,8, 3,8, and 4,64. Which means what? If it's x, and y is x cube, then the derivative function in this case is going to be as 3 is constant. So 3 times x square. So for x cube, it is 3 times x square. So similarly, if you have y is equal to x4, we can actually generalize it. If it's y is equal to x square, your y dash is 2x, right? If y is equal to x cube, your y dash is 3x square. So if y is x4, I can see what is happening here. So if this is 2, 2 comes here. And then what happened with the degree of x? It diminishes by 1. So here we have 2 minus 1. And if it's 3, then it's 3. And then 2 is 1 less than 3. So the degree diminishes by 1. So this 2 is 3 minus 1. So similarly for x4, so whatever is the degree, it comes in front as a coefficient, and then the degree diminishes by 1 for the derivative function. So I can generalize it now. So if you have y is equal to x raised to power n, then your y dash is equal to, so what happens here is this n will come down, and then this is x into n minus 1. So this is the rule for y prime. Okay, so I hope this is clear. And now we are going to move to, this is the, so we did y is equal to x square. I already explained. So this is this one. is equal to 2x, we already know. Now when you have y is equal to 2x square, we also looked at y is equal to 2x square. If you remember, we looked at y is equal to 2x square is 2x. No, for y is equal to 2x square, sorry, it's here. So we looked at y prime is 4x, okay? So similarly, if we have y is equal to 3x square, we need to, looking at the pattern, let's try to find what will be the derivative for 3x square. So if you look at, again, if it's 2, we know 2 comes in front and then you got x raised to power 1. So similarly here, we know that this 2 get multiplied by this 2 and we got 4x. So similarly here, looking at the pattern, it should be 3 times 2 and then x. So which means 6x. So that is your derivative of 3x square. Now if I want to generalize this, so let's say if I want to do y is equal to axn, I already know what is y rule for x raised to power n. The rule is nxn minus 1. And I also know that for x square, because 4x is 2 times 2x, for 3x square, it's 3 times 2x, and 2x is the derivative of x square. So for this one also, your y dash is going to be a stays same, and for xn, I already have a rule, so this becomes an xn minus 1. So this is the second rule. So in this case, we did two rules. Before I recap again the rules, I want to just remind you about the notations. So if you have y, so the y prime is the notation for gradient, or you can use dy by dx. If it's f, you use f prime. Now, so we already know the generalization for y is equal to xn, y prime is nxn minus 1. And for y is equal to a raised to power xn, y prime is a stays same and then n xn minus 1. So that is n a xn minus 1 or a n xn minus 1. So make sure that you take notes properly, and so far we did only two general rules. Now I'm going to do, because this was the next step where we ask you to do that again, if you want to find a pattern, I think which will be a very good way of doing. I'm not going to, or maybe I can show you one more time. So you go to math and then you go to number 8. Number 8 was in my case, which is the d by d of this, and then function, and x is equal to whatever is the number here. So I can show you one more time, and then you can do for all the remaining ones. So I have already written here. So the problem is that if I put it like this, there is a reflection. Okay, so d over x, and then I'm going to enter the function. Even much easier, what we can do here is, because I don't want to copy and paste this again and again, so what I can do is I go to y, and then for here I can actually go to math, and then I go to, this is even much easier and much cooler. So I do here, I enter y1 as d of y1 d over dx, and then I will enter my function, which is 3x square, and then I have, sorry, okay, this is at, okay, let me enter this and then I will show you on the screen. So here, so you go to math and then you go to n derivatives, okay, which we already did, and then I'm going to enter d by dx and my function. It's much easier if I enter out of the screen, then it's quicker. 3x squared plus 2x, and then my x is, I'm going to write x here. Okay, so this is how I entered it. So I entered d by dx and then 3x squared plus 2x, and x is equal to x. I did not enter any number here, and the reason is that I want to generate a table. So I'm going to go to second, and then I press on graph, and then I should be able to see the table. Okay, I hope it's clear. So if you look at the table, it gives me all the values for the derivative function. So y1 is my derivative function. So when x is 0, so I'm going to maybe note down here. So you already have access to these values. So I'm going to note down in my working here. So when x is, so here I have x values. So when x is 0, 1, 2, 3, 4, I think 4 values are sufficient to see the pattern. So y1, which in my case is y dash, for x is equal to 0 is 2, and then here it is 8, here this is 14, here this is 20, and then you have 26. So I copied the values from this table. And I think, if you are struggling with investigating patterns, this will be actually a good way of practicing investigating the patterns here. So now here you can look at, this is 6, this one is 6, this is 6, and this is 6. So it's a linear, it's going to be a linear pattern. So, and we know that because if it's a quadratic function, if you remember, the derivative is for x squared is 2x, which is a linear function. So for quadratic, the derivative is again going to be linear. Now, if it's 6, so what will be the rule for this one? So now 6 means it has to be, y dash has to be 6x. Now we need to see that if that is it, because for x squared it was 2x, or do we have to add or subtract anything? So if I go here, 6 times 0 gives me 0, but I need 2. So which seems like I have to add 2 here. So if x is 1, 6 times 1 is 6, but we needed 8, so I added 2. So y dash is equal to 6x plus 2. So this is how you find the derivative of 3x squared plus 2x. So now I can also, there is another way of doing it. This is, I did using GTC, generating the table values and then finding the derivative. Now here, what I can do here is 3x squared. So this is going to be 3 times 2x, plus we know the derivative of linear is a constant, and which is the coefficient of x. So this is 2. So 6x plus 2 is your y prime. So this is another and faster way of doing it. Now again, as I said, you can use the calculator feature by doing y1 and then using math and n derivative, which in my case was number 8, and then you will get d over d, and then you get a function, and x is equal to, and x, you have to enter x here. So here also you enter x, and here you do 4x minus 3x square, and then you can generate the table values. So you will go to second graph and your table will appear, and from there you can see the pattern. But if I don't want to do that, I know I'm going to use my knowledge so far. So the derivative of 4x is going to be 4, right? It's a linear one. And we know the derivative is the coefficient of x. Here, because I know the derivative of x squared is 2, and I need to multiply, the only thing I need to multiply that 2x with negative 3. So negative 3 times 2x, so that will be 4 minus 6x. So this is my y prime. And I can use that when x is 0, I can see that your y dash is going to be 4 here. And if you are doing using calculator, then that will be the table values which you get. When x is 0, your y prime should be 4. Okay, so this is how you find the gradient of a curve at a point. When x is 0, the gradient is 4. When x is 1, you get 4 minus 6, which is negative 2. When x is 2, you get x is equal to 2, you get 4 minus 12, which is equal to minus 8, and so on. Okay, so this is how you will find the derivative. Okay, so I'm going to move to the next example. So the next example here is y is equal to 2x squared minus 3x. So again, I'm going to do quickly 2 times 2x minus 3 times 1. Now the derivative of x, or negative 3x derivative, is negative 3. I don't have to write 1. So that is 4x minus 3 is your y prime. Okay. Now the next one, f of x. So I'm going to use f dash x notation. Now I can do, for 2x squared, derivative is 2 times 2x, and 5x minus 1 is a linear, and the derivative is the coefficient of, because y is equal to mx plus c, m is the gradient, you know that. So this is going to be plus 5. So that is 4x plus 5 is your f dash x. Okay. Now similarly, for negative half x squared, so negative half times 2x, derivative of 5x is 5. So that becomes 2 and 2 get cancelled, minus x plus 5 is your f dash x. Okay. I hope this is clear. Now for y is equal to 2, when you have a horizontal line, what is the gradient of this? Is 0. So always remember that when you have y is equal to c, y dash is 0. And that is the reason when you have 5x minus 1, the derivative of 5x minus 1 is same as the derivative of 5x, which is 5, because the derivative of 1 is 0. So in the previous one, I asked you to generalize it for y is equal to a0 xn plus a1 xn minus 1 and till an. But I haven't given you, because the only thing we did was finding y is equal to x square, and then with the only for the quadratic one. So I was not sure how would you do that. But to be able to do this, you needed to do for x cube, x4, so that you knew the formula for x raised to power n. Now we know what is the formula for x raised to power n. So y dash in this case is going to be n xn minus 1 a1. Now n minus 1 comes in front, and then multiply by x, and the degree of x raised to power diminishes by 1. And then a2, and then I'm going to use bracket here again, and then n minus 2 x raised to power n minus 3, and you can complete the remaining. And for an, I'm going to just write down the last one. This will be an minus 1 plus 0. So this is the generalization which I asked you to do in the previous one. I hope this is clear. Please make sure that you go back and do them carefully, okay? Now I'm going to talk about the first principle, and we'll be doing few questions on first principle, and your homework is going to be combination of first principle and finding the derivative the way we did. So this is any curve, and then when you have a point, let's say, now I'm going to generalize it. Let's say you have x, y is equal to fx is a curve, and we are talking about 2 points P and Q, and then you have x. So if x, for x point, your y is f of x, and if you change x by x plus h, then your y point becomes fx plus h. So if I ask you what is y when x is equal to 3, then you will say y is f of 3. So similarly, when I ask you when x is x plus h, so what is y? So y becomes f of x plus h, okay? Now if you have 2 points, we know this distance is x, okay, and then this distance is x plus h, which means from here to here this distance is h. Now we know how to find the slope of this chord PQ. We have both the points here. So here this will be f of x plus h minus f of x divided by x plus h minus h. Now this x and x get cancelled, so you got f of x plus h minus f of x over h. Now if you remember how we were finding the gradient of a curve at any point, we were fixing the end point, any point that, like in this case is q, and then we were moving p towards q. When we move p towards q, so this is moving towards q, which means your h is approaching to 0. This is how we say that. So when p moves towards q, then what is happening is h approaches to 0. Okay, h approaches to 0 means, and how do we write down this, is called limit h approaches to 0. So lim is the short notation, and then you get f of x plus h minus f of x divided by h, lim, h approaches to 0. This gives you, what does this gives you? When you move it, it gives you the derivative f prime x, and this is called the first principle. So f prime x, so this f prime x is the gradient of a curve. Please make sure that you take the notes carefully, of a curve at point q, and is also a gradient of a tangent at q. Remember, when we move this P and Q, this line, which is a chord, is no more a chord. It changes into a tangent. So it will be like this. So that means the slope which you are finding is not only the slope of fx at q, but it is also a slope. It is a function, right? F dash x is the slope of this curve. And then it is also a gradient of a tangent at q. So make sure that you know that whenever you are finding the gradient, f dash x is also the gradient of a tangent at q. It's quite important that you need to know that. And this is called the first principle. So this is your first principle. Now I'm going to do few examples so that it will be clear to you how to use the first principle. Okay, so I'm going to start with y is equal to x square, and please be careful, you write down the steps carefully. I already know how to find f dash x, right? Remember, for xn, the formula is nxn minus 1. So we already know this is 2x. Now using first principle, what we need to do is, your step number 1 is f of x plus h, and which in this case is x plus h whole square. Step number 2, you do f of x plus h minus f of x, which gives me x plus h whole square minus x square. Step number 3, you divide by x plus h square minus x square divide by h. So in step number 3, you do fx plus h minus fx divide by h. Now I have to simplify it. When I simplify, I know a plus b whole square, so this is 2hx plus h square minus x square over h. This get cancelled, so the original function will always get cancelled. If it does not get cancelled, which means you did something wrong. Now I can see from here, your h is common, so that gives me 2x plus h divided by h. And this h will should also cancel, because what is the problem here? If I will approach h to be 0, then we have 0 in the denominator, and which means it's undefined. So that is a problem. So before we start saying that limit h approaches to 0, this h should get cancelled. So that is your step number 4. Step number 4 you say is fx plus h minus f of x. This was step number 1. Then subtracting was step number 2, divide by h was step number 3, and then in step number 4 you say limit h approaches to 0 after you simplify. And I had 2x plus h, and when I did limit h approaches to 0, I got 2x. H approaches to 0 means this is going to be 0.000000 something, which is negligible. So we can ignore this. So the derivative is 2 of x. I hope this is clear. Now the next one is f of x is 2x square. So f prime x we know is 4x. Now I'm going to do using first principle. I'm not writing all the steps, but I'm going to follow the steps. So fx plus h is 2x plus h whole square. Then you have minus, so 2x plus h whole square minus 2x square. Now I'm going to simplify it. So this is 2x square, 2hx plus same steps. Okay. And now open and simplify, plus 2h square minus 2x square. As I said, this should get cancelled. Next step, divide by h. And now h is common. So 4x plus 2h divide by h. So limit, last step, limit h approaches to 0, which means this is negligible. Negligible. Derivative in this case is f dash x is equal to 4x. Okay, so I hope this is clear. Please take your time to do the practice. Now I'm going to do is 2x squared plus 3x, and I'm also going to do using first principle here. So here y dash is 4x plus 3. We already know for 2x squared is 4x, for 3x is 3. Now I'm going to do using first principle. So I'm changing y to f of y, okay, f of x, sorry. And then I'm going to do fx plus h, which is equal to this. And then next step, if you remember, we subtract. So this is going to be 2 into x plus h whole square plus 3 into x plus h, and then minus 2x squared plus 3x. Please use brackets. And now I can open x squared plus 2hx plus h squared plus 3x plus 3h. Take your time. And then I have minus 2x squared minus 3x. I'm going to open again. 2x squared, 4hx, 2h squared plus 6x plus 6h minus 2x squared. And remember, the original function should cancel out. Oh, okay. So there seems like some problem here. Yeah, so this 2 was only actually in front of that, and that is the problem. So 2x squared, 4h, 2h squared, this is 3x, and this is 3h. See, I noticed my mistake. So this get cancelled, 4hx. And now, next step is we need to divide by h. And then you will have h common, 4x plus 2h plus 3 divided by h. And now, last step we need to do is divide by h. And then we need to do is limit h approaches to 0. So here limit h approaches to 0, which means this is negligible. So 4x plus 3, this is what you got in the previous one. So I'm going to do next one. We already know for y is equal to x squared plus 4x, derivative is 2x plus 4. And now I'm going to do using first principle. I'm going to change this into, so again, fx plus h is equal to, same steps, 4x plus h, and then you will get x squared plus 2hx plus da-da-da. Okay, maybe you should complete it. So complete it, please. Okay. Then the next one is y is equal to 4x. So y, again, f of x is equal to, now, how to use the formula actually here? So I can write this as 4x minus 1, okay? So if I want to use xn, I know the formula is nxn minus 1, but since we didn't do anything with negative numbers, so let's see if it is working for that or not. So that is minus x raised to power minus 2. So minus 4 over x squared should be our answer. Let's check it using first principle. So if I do it, this is x plus h, which is f of x plus h. And the next step we need to do is f of x plus h minus f of x. So that is, I'm using bracket here, notice. And now we need to make the denominator same. So this, and here this. So we got x into x plus h. And this is 4x minus 4h. And notice, this get cancelled here. And our next step is divide by h. So if I divide by h here, this will get cancelled. So you got minus 4x plus h. And now we have to do limit h approaches to 0, which means this is cancelled and you get minus 4 over x squared. So we got the same answer, which means x raised to power n, y is this, y dash is n xn minus 1, also work for when n is integers. So we already know that. Okay, so I hope this is clear again. And now I'm going to do actually for y is equal to x to the power of half. If I want to use xn, which means it's n xn minus 1. So that here it will be 1 over x raised to power. According to the formula, I should get this, which is 1 over 2 square root of x. Now let's see using first principle. So again, f of x is equal to square root of x. So f of x plus h is equal to this. And then you have x plus h minus f of x. So you got, now divide by h. But now if I do limit h approaches to 0, I will have 0 in as the denominator, and that's the problem. So what we need to do is we need to rationalize it. So I'm going to rationalize it. Plus square root of x. Here, this is a minus b, a plus b. So this is a square minus b square. And then you have this. Okay, this is divide by h. So I'm writing it here. This get cancelled. And now this get cancelled. And when you have limit h approaches to 0, this is cancelled. So you get is 1 over 2 square root of x, which is same as this one. Okay, so please make sure that you pause the video because it's quite difficult. So make sure please you do that. Okay, so I'm going to do that. They said y is equal to minus x square. Estimate the gradient of the tangent to the curve at this. So I'm going to, this is from your textbook. I'm not going to write estimate. I'm going to say find the gradient here at x is equal to 1, at x is equal to 2, x is equal to 1 over 1/2. So I'm not using first principle here, but if you want, you can do practice with first principle also. But always do the first principle when they ask you to do, otherwise you just do using the formula. So for y is equal to, before I do, I also forgot to say, so this seems like this formula works even when n is the rational number. So n can be anything for this formula. So it could be a fraction, it could be an integer. So and it works for all, okay? Now for this one, I already know, find the gradient of the tangent to the curve y is equal to minus x squared. So I'm going to just, draw this. We know y is equal to minus x squared looks like this. So tangent to the curve at x is equal to 1. Let's say x is equal to 1 is this. So the tangent is this, okay? So we know the derivative function is y is dash is minus 2x. So for x is equal to 1, what will happen here is your y dash is going to be at x is equal to 1, derivative is going to be -2. So this is how I actually write down when they ask you derivative at a specific point. So I put a line and then x is equal to 1 is -2. And again, this is the gradient of this function at x is equal to 1 and 1 and -1. So x is equal to 1, the gradient is -2, and this is also the gradient of the tangent to the curve, because that is, they share this point. So if this is the gradient at x is equal to 1 for this curve, then this is also the gradient of the tangent at that point. Okay, so similarly you can do x is 2, x is 1.5. So this is what you have to do as a homework. Okay, and also, you know, for this question you don't have to do the first principle, but what you have to do is, this is a homework, you do this question again. Okay, and then you have to do this one. Okay, I already did the first principle, but you know, your task will also be kind of like taking notes and doing the examples which I am doing. Okay, so 4 over x, same thing. Okay, and then y is equal to square root of x, same thing. So this is the homework you have to do, and that's it for today's lesson.